Hello friends, welcome to our channel Dr. Topper BDS. Today we will study about the physical property of dental material. The question from this portion is important for Viva as well as for your exams. Watch this video completely without skipping any portions before we begin. Please subscribe our channel, comment and share your feedback. If you like my video, please share it with your friends also. Moving to the topic, what is the need for studying the physical properties of dental material? It is so simple that for the proper selection of dental material, we should have to know the physical, biological property of a dental material as well as its biocompatibility, applications, and also the performance of it. In this video, we are going to study topics stress and strain, Poisson's ratio, proportional and elastic limit, yield strength, modulus of elasticity, resilience, fatigue, toughness, and brittleness. Begin with the first topic, that is stress. When you apply force to any object, an resistant force is developed in it which opposes this force. Now, what is stress? The internal reaction of the body to the external force. Stress can be expressed as force per unit area. Clearly, stress is said to be the force per unit area acting on the surface of a material. Stress is also the internal resistance or counter force of a material to the distorting effect of an external force or load. Hope you all understand the definition of stress. This internal resistance tried to return the atoms to their original position. The total resistance developed in the material is equal to the external load applied. This resistance is known as stress. Stress is actually a resistance. Moving to the equation of the stress. Stress is force per unit area. From this equation, if we analyze this, it is clear that stress is directly proportional to force and it is inversely proportional to area. That is, as the applied force increases, stress also increases. And if the applied area is small, then the stress will be higher. So, force is directly proportional to stress and area is inversely proportional to stress. And its application in dentistry. As area present in dental restoration is very small, because of this a high amount of stress is developed in the filling. Stress can be mainly classified into three types. That is tensile stress, compressive stress and shear stress. Moving to the first type of stress, tensile stress. Do you know what is a tensile force? A force that results in increase in length along the direction of the force is called a tensile force. The stress developed by this force is tensile stress. If we consider a table, the stress it tends to here we are applying a force. It tends to stretch the table. In this picture, we can see that two forces are applied in opposite direction so that both of the force will tense the table to stretch. The stress that developed in the table because of this stretching force is called as tensile stress. To summarize, The tensile stress is the stress which is developed by two sets of forces that are directed away from each other but in the same line. Now, talking about compressive stress. A force that results in a decrease in length along the direction of force is called compressive force. The stress developed by this force is called compressive stress. Compressive stress is caused by the force that tends to compress the body. Suppose this is a table T and two sets of forces are applied to this table such that force tend to compress the table. So the stress developed here to compress the table is called as compressive stress. To summarize, the compressive stress is the stress which is developed by two sets of forces which are directed towards each other in the same line. Now, what is shear stress? The shear stress is caused by a force that tends to twist a body. Suppose this is a table and two forces are applied to this table in a way that they are opposite in direction. Suppose this force is directed in a direction shown in the figure. Here it is directed in this direction. They are opposite to each other but they are parallel to each other also. Now these forces are applied to the table. The stress that developed in the table is called shear stress. A force that causes a sliding displacement of the structure relative to another side is called shear force. The stress developed by it is called shear stress. Moving to the next topic, that is strain. Hope you all understand what is stress. Now we can look what is strain. Strain can be defined as deformation of a solid due to stress, as it is the change in length per unit length that a material undergoes when force is applied to it. Applying this knowledge to restorative material, in case of dental fillings, forces of mastication applied to this filling. If the stress produced due to these forces are not enough to withstand these forces, this dental filling undergo deformation. Next type of strains. There are mainly two types of strain, that is elastic strain and plastic deformation. First one, what is elastic strain? Transitory or temporary dimensional change that occur only when the initial stress is applied. Once the stress is removed, the elastic strain and dimensional change will disappear. Next type, that is plastic deformation or strain. It is a permanent dimensional change which once it occurs does not allow the material to return to its original dimension even after the initiating stress is removed. Hope you all understand. The combination of all the three stresses, that is tensile stress, compressive stress and shear stress, produces a complex stress. Next, moving to the next topic, that is Poisson's ratio. What is Poisson's ratio? If we consider a cylinder and subject it into a complex stresses like tensile stress, which tends to elongate the cylinder, the compressive stress, which tends to compress the cylinder, as well as the shear stress, which twists the cylinder. What happens when the complex stress is applied? We will then have a concept called as Poisson's ratio. This Poisson's ratio is the ratio of the lateral strain to the axial strain. As a result of this complex stress, lateral strain as well as axial strain is produced in the cylinder. The lateral strain will direct the cylinder laterally and the axial strain will direct along the long axis of the cylinder. Now we can look the clear definitions of Poisson's ratio. If a tensile load is applied to a material, the material will elongate along the direction of load, that is axial direction. Conversely, if the load is compressive, the axial dimension will decrease while there will be an increase in the cross-sectional dimension. Providing the fact that the volume and density are fixed, a change in one axial direction results in change in lateral direction. This change in lateral direction bears a fixed relation with the axial direction. This relationship or ratio within elastic limit is called as Poisson's ratio. The definition of Poisson's ratio is very much important, that it will asked frequently in your exams. Moving to the next topic, that is very important, stress strain graph. As we all know that when a stress is applied to a body, there will producing a strain in that body. What is the relationship between stress and strain? It can be identified from a graph drawn between the stress and strain. That graph is called as stress strain graph. That is, stress and the resultant strain and their relationship is better described graphically by stress strain graph. The picture shown below is the stress strain graph of a material. The graph can be explained in the following ways. There are so many points in this graph. When the examiner asks the question about stress strain graph or what is stress strain graph, we should specify the points in the graph and what does it means. The graph can be explained in the following ways. As stress is applied to a material, strain is produced. Initially, this strain is proportional to the stress applied. This is represented by the straight line up to the point A. That point A is called a proportional limit. This is the point of proportional limit. Next we have the short line from proportional limit to elastic limit. Represent the elastic strain or deformation where the strain is not proportional to stress. Elastic limit is the up to elastic limit, the deformation of the material is not permanent. The material can take back into its original shape and dimension. But the difference between the proportional limit and elastic limit is that up to proportional limit, stress is directly proportional to strain. That point is called a Hooke's law. Stress is proportional to strain up to proportional limit. But from the proportional limit to elastic limit, the material can retain its original dimension, but the stress is not proportional to strain there. The slope of the straight line up to proportional limit represents the modulus of elasticity. We can deal it with later. Next we have the elastic range is the amount of the stress that the material can withstand within the elastic limit is called the elastic range. The point O up to elastic limit represent the elastic range. The line from elastic limit to the fracture point represent the plastic range. The area under the entire length of the line up to the fracture point represent the toughness of the material. The fracture point is the point where the material breaks. Now we can deeply describe each and every point in detail. First we have proportional limit. Proportional limit is the amount of stress that is required to produce elastic deformation of a material, at the same time maintaining the proportionality between stress and strain. That is, up to proportional limit, stress is proportional to strain. It is the limit up to which stress is proportional to the strain. It can be defined as the stress level at the maximum elastic strain just before plastic strain. It can also be defined as the limit of proportionality of stress to strain. Hope you all understand what is proportional limit. Moving to the next topic, that is elastic limit. The proportional limit and the elastic limit both represent stress and these terms are often interchangeable. Elastic limit is the maximum stress that the material will withstand with the permanent deformation. Next we have yield strength. Beyond the point proportional limit, stress produced is called as yield strength. Yield strength is always more than proportional limit or elastic limit. Next we have modulus of elasticity. As described earlier, it is a measure of relative stiffness or rigidity of a material. However, it applies only to the elastic portion of stress strain diagram. The slope of the stress strain graph up to proportional limit represent the modulus of elasticity. If the slope is more, then we can say that the material is highly rigid material. Its clinical application. The impression material should have a low modulus of elasticity to enable it to be removed from the undercut areas in mouth. But at the same time, the modulus should not be very low that the material cannot withstand tearing. In case of restorative materials, generally the modulus has to be high. That is, the material have to be stiff enough to withstand the forces of mastication. On the other hand, a material with lower modulus used to restore class 5 lesion since the material has to possess better flexural strength. Next topic is flexibility. It's more important in ortho applications. When a small stress is applied, a string need to tend considerably to a great distance. Looking to the definition of flexibility, we can say that flexibility, if force is applied to a body, the strain that occur when material is stressed to proportional limit. The strain at that time is called maximum flexibility. Modulus of elasticity is the ratio of proportional limit and flexibility. Now, let us study what is resilience. Moving to the definition of resilience, the resistance of a material to permanent deformation under a sudden impact. When a material is stressed to a point just below its proportional limit, the amount of energy that the material absorbs may be defined as resilience. Application of resilience. A high modulus of resilience is desirable in restorative dental material. In case of orthodontic wire, the resilience enables the wire to store energy which may be delivered to required teeth over an extended period of time. Next topic, that is fatigue. It is associated with the material subjected into cyclic loading. This type of loading causes surface cracks on the material, which is further lost due to sliding action under the contacting surface. Next we have toughness. The toughness of a material is its resistance to fracture under a sudden impact. It can also be defined as the amount of energy absorbed by a material when it is stressed to a point just short of its fracture point. Then we have brittleness, a material that will undergo fracture or rupture with little or no prior permanent deformation when excessive load is applied. Remaining property, sorry, This is because material that are brittle usually have a very ordered atomic structure which does not permit easy movement of atom for dislocation. Example, glass and ceramics. The remaining property we'll discuss in our next lecture, Physical Properties Part 2. Thanks for watching. Please like our video, share your knowledge with your friends also. Don't forget to subscribe our channel, give your feedback on comment box.